So good evening and welcome to New Space Chicago. Thank you for all coming. We appreciate your support. For those of you, how many of you, this is your first time here? Just hands. Great, that's good. Glad to see you coming out. So New Space Chicago is a community of space entrepreneurs, experts, investors, and other people who are interested in space, but also interested in building commercial ventures that are related to space that are located in Chicago. So we want to foster space entrepreneurship and really build Chicago as a center of excellence in the space economy. And so that's what we're all about. We have these events more or less on a monthly basis to get people together, to build the community, to exchange ideas, make connections, and really make things happen. So I'm really glad to see you all here. I appreciate your support. A couple of announcements. First of all, if you have not found the restrooms, they're back down the hallway that you came down, about halfway down on the right. Secondly, I'd like to give a shout out to our sponsors. First of all, we're very appreciative of MHub for providing us with this great event space. MHub is an incubator for companies that are building products and a manufacturing innovation center. And I encourage you to get a tour of the space afterwards. We'll see if we can arrange a tour for you. I also want to give a shout out to Metropolitan Brewing. They have graciously provided the beer that we had this evening. They are a local craft brewery and also a startup company. We appreciate that very much. So before we get started with the main program, I would like to introduce Dave Cook, who is one of our directors of New Space Chicago, and he would like to tell you about the Aerospace Workforce Coalition. Dave.
Hello, thanks for coming. I've been involved with New Space here for just a little bit more than a year. I'm an entrepreneur. I like to start businesses. I have a business that I started about 3 years ago called Air Chicago. We're a new kind of private jet service where folks who are traveling on the airlines today can afford to fly on a private jet and save a lot of time and gas. A lot of you folks here fly on the airlines. You should look at Air Chicago. That's the only commercial I'm going to give for Air Chicago. The reason I'm involved with New Space is I really believe in what Dave is doing. He's kind of the pioneer here to make Chicago a center of excellence for commercial space development. And you know, it's amazing that Chicago isn't that already with all of the resources we have here that could make that happen. Dave's been the leader of a team. I'm on the board of directors. Steve Wasco, Eric, Brendan, and there was somebody else here on the team. We've got a small team of folks, committee chairs and so forth. We've been working to make this all come together, and we're here to help you. If you've got an idea that you think would work in space, you want to start a business, or if you want to work for somebody that is starting up a space-related business, that's really what we're all about here. We kind of the melting pot. So please continue to come to the meetings, and anything we can do to help you, just let us know. What I want to tell you about briefly is as part of all of solving the problems that we need to solve so that humanity can move off the planet and come back whenever they want, just like an airline operation, is we obviously need a lot of highly talented and skilled people. The aerospace industry right now already has a shortage of those kind of people. I'll give you one example, pilots. I used to be a pilot for United Airlines. Right now, the airlines around the world are short several thousand pilots. In fact, Emirates, one of the biggest international carriers on the planet, just reduced their schedule by 17% because of the shortage of pilots. We're also running into shortages of maintenance personnel to service the jets. So we need to bring in more young people into the aerospace industry. And if you've looked at career opportunities in aerospace, you've already discovered it isn't just about pilots and mechanics and engineers. It's about managers, it's about accountants, it's about medical people. Almost any career path that you can think of has a counterpart in the aerospace industry. So we are forming a new coalition here in the Chicago area called the Aerospace Workforce Coalition. The purpose of the coalition is to establish a network of aerospace clubs in all of the high schools in the Chicago area. Air Chicago is a sponsor of the coalition. We believe New Space will probably be involved in it too. We just started talking about that. Of course, we have United Airlines, Boeing, big aerospace companies here in Chicago. So those are the kind of folks that we're going to be putting together to start bringing more young people into the industry. The reason I wanted to make you aware of this tonight is we also need a lot of good people to make that happen. So if you have any kind of an interest in helping to make the coalition come together and then make it go, I'd like you to let me know after the meeting tonight. So thank you very much. I want to let you get on to the main event because I'm anxious to hear about it.
Thank you, David. So this evening, our special guest is Eric Reiners from Caterpillar. And you might wonder, what is Caterpillar doing in space? That Eric will be telling us. Eric is program manager within the Innovation and Technology Development Division at Caterpillar. He is responsible for program definition and funding for Caterpillar's research focus in automation and IoT site technologies. He also serves as the Caterpillar liaison for program activity with NASA. His past collaborations with NASA include telerobotic and automation technologies that were showcased in NASA's exploration highlights. Current collaborations include the NASA 3D Habitat Challenge, which we'll find out more about tonight. Eric has also served as a judge for the NASA robotic mining competition since its inaugural year in 2010. And he is also a member of the Commercial Advisory Board for the Lunar Exploration and Analysis Group. So without further ado, let's please welcome Eric Reiners.
Thank you, David, and thank you all in the New Space Chicago community for having me tonight. As David referenced, I'll be covering and talking about NASA's 3D printed habitat challenge and NASA or Caterpillar's involvement in that challenge. So I'll cover the NASA's Centennial Challenge program and give you a little bit of overview of that, as well as some history of Caterpillar's interactions with NASA, and then the specifics about the 3D printed habitat challenge and what's already transpired in phases 1 and 2. Those are now complete, and I'll give you a little bit of a historical perspective of that and what transpired. And then what's now happening as phase 3 starts to occur right now. And then I'll finish with ways that you can actually engage if you see interest in that from what you see tonight. So I'm going to start with a short video on the history of Caterpillar and NASA, and a little bit about the Centennial Challenge program, the 3D printed habitat challenge program, to start off.
Man's desire to conquer new frontiers was only ever limited by the imagination of those leading. Reaching for the stars, conquering the harshest conditions, applying new technologies. Caterpillar and the National Aeronautics and Space Administration, NASA, have partnered for progress from the Earth to the Moon and beyond. CAT and NASA have been working together as far back as the Apollo program in 1969. When CAT generators powered the communication systems between Apollo 11 and NASA tracking stations. This allowed Neil Armstrong's famous words, "That's one small step for a man, one giant leap for mankind," to be heard around the world. And that was just the beginning. More recently, it's been a focus on technologies that NASA can apply in space and can benefit Caterpillar customers on the ground. The joint research emphasized areas of robotics, as well as semi-autonomous and remote operator systems, both of which help keep people safe in hazardous environments. And remote sensing and controls originally designed for work on Mars have been adapted for machines on Earth. It continues today, as NASA makes plans to put astronauts on Mars in the next 20 years. Caterpillar is partnering with Bradley University and NASA for the 3D Printed Habitat Centennial Challenge. The challenge seeks to develop 3D additive construction technology needed to create sustainable structures and housing solutions using local indigenous materials. And they're looking at additional applications for these structures here on Earth, now and in the future. For Caterpillar and NASA, collaboration is about advances in infrastructure, resource utilization, and inspiring the next generation of innovators, discovering new ways for NASA to meet its mission directives and Caterpillar to meet the needs of customers around the world. The possibilities are endless, from the Earth to the Moon and beyond.
So that gives you a little bit of background on some of the things that we've done with NASA, how those have translated into actual commercial product. And now I'm going to really focus in on the Centennial Challenge program. And the goal of the Centennial Challenge program for NASA is really about incentivizing innovation and R&D in areas that will support NASA's mission objectives, but to do that in a way that is a little bit more non-traditional from the majority of their focused work in innovating or driving innovation and driving engagement of people that may not normally engage with NASA. So through this incentivized program and the prize money, it's really helping to reach out to this more diverse community of innovators. So you can even get into where we have people entering into the competition that might be working from their garage, as an example. And the other big focus area for them is, in doing all of this, is to create new capabilities in commercial markets more terrestrially here for the U.S. nation as well. So these are the current Centennial Challenge programs and activities that are going on. There's 4 that are active and then 1 that's under development. And you can see the wide range of focal areas that they have. So there's things that you might think are more traditional, where you would recognize with NASA in the area of cube satellites and in-space propulsion, etc. But you also see in the area of tissue research, biomanufacturing, so some areas maybe that don't first come to mind when you think of NASA as well. And then, of course, the 3D Printed Habitat Challenge. So the 3D Printed Habitat Challenge is focused on advancing additive construction. So additive construction is very analogous to additive manufacturing. So we're talking about to be able to construct a structure layers at a time. So it's like your tabletop printers that you may have around in different innovation labs. Many of them now are at homes. It's just on a much larger scale. Phase 1 of this competition really focused on the architectural concepts that could take advantage of this new and unique approach to developing structures. Phase 2 of the competition focused really on the material itself. So the material formulation and the strength and the structural performance of those materials. And the rules for the competition are actually constructed to drive and incentivize the competitors to look at recyclable materials as part of that formula. So they will score very well, for example, with a material that is based on basalt, because basalt is very prevalent on the moon and on Mars, but with polymer-based binders. So things like high-density polyethylene. So the plastics that are in water bottles. So some of us are drinking tonight from water bottles and so on. So to be able to take those kinds of plastics and marry them with basalt material to create a structural material will score very well. So that works very well for us here on Earth, because those kinds of materials, plastic bottles, for example, are very prevalent around the world in recyclable, but unfortunately also in waste streams as well. So if we can come up with a structural material based on that drives more value to those products, then more of them will get out of the waste stream and really into more recyclable streams. And so for NASA, the vast majority of their logistics material that they'll take on a mission are packaged in those kind of plastics. So now they can now turn around and use that material to generate or create structures. So it's part of a focus of in situ resource utilization, or ISRU. And many of you here in this community, maybe you have a focus on that, I don't know, but it's a very relevant topic for NASA. And as they go to Moon and into Mars, certainly in a way that is not just footprints and flags, right? But more for a sustained presence, multiple missions, and so on. They'll be bringing a lot of that packaging material. So one of the things we don't want to do, I think all of us, as taxpayers, et cetera, and with NASA, is to see the first extraterrestrial landfill because of our efforts to expand humanity out of the solar system. And then phase 3 focuses on really to bring all these together and the design of an actual habitat, subscale habitat, and the system to actually print that. So this is are the top 3 winners of that first phase I mentioned, the architectural phase. And you can see the designs that they came up with in that phase that focused on using their imagination and really exploring with this kind of a approach to construction, what could you potentially build? And then we get into phases 2 and phases 3 that I just talked about. Before I get into the details of that though, I want to give you a little bit of understanding of how it's structured in terms of execution. So NASA, of course, is bringing in the prize money that you saw on those previous slides. And they are partnered, or they have an agreement with Bradley University, who's also in Peoria, Illinois, as their allied partner. So this is a non-for-profit allied partner. Bradley then has teaming agreements with the competitor teams as they engage to be in the competition. And then they have a sponsorship agreement with Caterpillar to support them. And then we in turn have sub-sponsorship agreements with Bechtel. So this is one of the largest construction companies in the world, and a significant customer for Caterpillar. Brick and Mortar Ventures, they are a venture capital company out of the Silicon Valley area, and their focus is also on driving innovation and development in the construction industry. And then the American Concrete Institute. And then also the U.S. Army Corps of Engineers are involved through a memorandum of understanding between DoD and NASA for them to engage as well, because they're also interested in exploring some of this technology for use within the military. So phase 2, again, this is completed, but let me give you a little bit about the structure of the competition. So there were 3 levels. Level 1 started with the truncated cone and cylinder. So this focused on, the truncated cone focused on the slump characteristics of the material. So this is how it flows out, or flows as it's setting up. And then a cylinder, which was used to evaluate the compressive strength of the material. Then in level 2, it was a beam member, and here you can see down below some of the entries that were, an example of an entry that was submitted for the cylinder. And then level 2 focused on beam. The beam member was really about the flexural strength of the material. And you can see an example here of an entry for level 2. And then level 3 was a head-to-head competition of the competitors, where they were required to repeat printing 3 of the cylinders, 3 of the beams, and they were averaging out their structural performance, and then a fairly complicated dome structure. And level 3 of that competition took place at Caterpillar at our Edwards demonstration and training facility, which is just outside of Peoria. And this will give you a little bit of perspective then of that venue. And in these photos you can see this was the testing of those dome structures. And if you can look closely here, so we were loading these to failure. And we had a nice little run-out screen here that you can see how much load was developing until it actually failed and so on. And so this was the dynamic part of the competition and what really drove a lot of excitement and following actually on social media. So I'll touch on that in a moment. But in addition to the actual competition itself, then there was a lot of other activities that were taking place with it and around it. So there was a heavy focus on STEM outreach. So NASA had a retired astronaut at the competition, and we allowed people to sign up, to reserve, to come in, and we also brought in local students. So we had students from the local community as well as community members coming in to participate in the activities. So the discussions with the astronaut were very well received, and the students really enjoyed that heavily. We also had virtual reality simulators so people could experience what it would be like to maybe walk through a Martian environment. And then there was a host of other kind of STEM outreach, educational type materials through Caterpillar, Bradley University, and the other sponsors. If you look here in this photo, under the glass here is actually a lunar sample, so a moon rock that NASA was able to bring in. So this also was a big hit for the community and for the students as well. So level 3 of phase 2, there was a significant amount of publicity for that event. A lot of local media in the Peoria area, through newspaper and television stations, obviously, and then social media for NASA. And so they actually live streamed the event on their Facebook page, and this event was their second highest viewing event behind the lunar eclipse, which had actually happened at the beginning of the week of this event was the lunar eclipse. So it was a pretty big success from NASA's standpoint too in terms of social media engagement of the public. And these are the two winners of level 3 of phase 2. So Branch Technologies out of Tennessee received first place in $250,000 of prize money. Their focus was on a basalt polymer mix, so the kind of material I was referencing earlier, which allows them to freeform print the dome structure. Penn State was second place with the $150,000 prize, and their material was focused on a cementitious-based basalt, so you can think of that as like Martian concrete. So for them, they had a collapsible form that would automatically collapse after they had printed it and had a little bit of set time so it could hold its shape. Now phase 3. So phase 3 is really broken down into two major work streams or focus areas. There's a design virtual construction, which is involving BIM or Building Information Management System, which is heavily used in the construction industry. And then the actual subscale construction of the habitat. So with the virtual construction, it is broken into 2 levels. So level 1, design development, 60% complete. As you can see, we just received here a few weeks ago the submissions for this level 1. 60% complete on the design, and they're looking at some of these kind of parameters in the judging of it. The completeness of the model, layout programming for the actual habitat structure itself. What is the scalability and constructability of the model that they're designing, and its aesthetic representation. Then level 2 will focus on really getting to a complete design. This will be in January of 19. Some of the same parameters, but now based on the completion of the design, and then also this optional aspect, bringing in more of the site layout, as well as the 3D printing and the autonomous feeding system, the actual system that's required to actually print or construct that design or structure. And then in the subscale construction, it's broken down into 3 levels. So the first level focuses on the foundation, and they'll be evaluating it on its material performance, the structural capability, the autonomy capability of the system that actually prints that, and the quality and durability of the material as well. So that's targeted for July 11th. So there will be there's a set of rules around all this, and the teams will do this locally at wherever they're located at, using registered testing facilities, etc. And then they'll submit that in. Same thing for level 2, they'll submit that in as well. It'll focus on hydrostatic leak testing. So again, the structural performance, an aspect of the autonomy, the ability to print and now place some of the sealing members of the structure into place, and now how that performs in terms of leakage and sealing. So can it contain an atmosphere, essentially? And then level 3 will be, again, a head-to-head competition and construction of a 1/3 scale habitat for those designs. Again, it'll focus on the material performance, the autonomy element, the ability to do that, and the structure's robustness. And that will happen at the end of April, beginning of May of next year, 2019. And you can see these are pretty significant prize available to the teams. So that will take place, that head-to-head will take place again in Peoria area at our demonstration area, as it did in phase 2. And as I wrap up some of this, I wanted to focus on that it's not just about space. So it does benefit NASA greatly, but there's tremendous benefit here terrestrially. So planet Earth needs 350 million additional homes built every year. There's huge increase in demand out through, if you look at the forecast through 2020 worldwide. The construction industry in general has been stagnant, if not actually decreasing in productivity levels, especially when you compare that to manufacturing and even agriculture, where we've seen very significant increases in productivity over the last few decades. The construction industry has been flat or actually declining. So there's a huge demand or need for automation, autonomy, new techniques in construction to be able to address this productivity issue and meet this ever-increasing demand for habitat around the world. And so this is just a quick video to give you a little bit of a notional vision about the kinds of things that may be achievable with this kind of technology. Because you are not constrained to more of the rectangular vertical construction that we see, right, typically today. This technology really allows you to explore some very unique designs and shapes in your architectural structures. So how can you get involved? If you have an interest in getting involved, www.bradley.edu/challenge. And at this location, you'll be able to find out information about registration, the rules. There's a whole list of FAQs there. You can submit questions and inquiries and get a response back to that. And also the timeline of the dates that I just showed you will also be there as well. So that's a way for you to get engaged and reach out and hopefully participate if this is an area of interest. Through that website, there'll also be an opportunity for you to reach out and find other teams or other people that are looking for somebody to be able to team up with as well. So with that, I'll open it up for some questions.
All right. A question about the phase 1 results. Can you elaborate on how the one over the other in terms of, because it was the infused basalt versus the concrete. Can you talk a little bit about how one beat the other?
Yeah, to be honest, I don't know the details of that because we weren't involved yet when phase 1 occurred. So that was before our and Bradley's involvement. So I don't know the details of the rules that transpired for phase one and how that was judged to answer that, unfortunately.
Can you say more about the differences between the two competitors?
Between the two competitors of phase two.
Phase one.
So there was Branch Technologies out of Tennessee. They are a startup company in Tennessee, and then Penn State University. There was another team that actually competed. It was a South Korean university, but they were not able to meet all the requirements to actually place and receive an award. Well, actually, and they also cannot receive award money as well because they're not a U.S. national. So only U.S. national entities are allowed to receive the prize money.
Eric, part of the success of humankind has been coming together to address issues and develop. Cities are part of that. I guess that what I'm trying to say here is that let's not forget that when we talk about habitat, it's about collaborating. It's about not just shelter, but creating the conditions so that we could, as a human and as a species, keep progressing. So the key element here is that we need to build community. This nation itself is based on that community effort. Progress has been built on community efforts, and we need to create communities that are productive, that are efficient, that are collaborative, that are solidarious between each other. And I guess that that's here true in Earth and true in space. I think that this is fascinating, but it is not, we need to go beyond just shelter. We need to go to create conditions for humans to thrive.
Is there a question?
I'm sorry, because I was passionate about that.
And there is an aesthetic aspect to this, to the rules and to the judging of those design submissions. And through the Bradley website, I think some of those level 1 submissions for that virtual design for the teams that have decided that they're ready to make those publicly seen. Some of them aren't yet because it's part of their strategies. They continue to move through competition. They're not ready for everybody to see that. But some of them are and are making those public. I think one of the submissions was from Eastern University, so here in Chicago. And theirs, I think, is on their own website. It's public.
Yeah, we want to know, what about the mechanical and electrical systems? Because, I mean, you could put a shelter up there, you're still going to need mechanical and electrical systems, right? That would have to be manufactured up there.
So it will remain to be seen the specifics of how NASA, or perhaps there'll be some other people that actually end up doing this, propose to do that. For right now, this competition is focused on the structure itself. I think that we will probably see, though, for the completion in some of these designs that are submitted in BIM, on how they plan to finish out the interior of that structure, which will include those mechanicals that you're talking about. So the videos that I've seen that are posted out, that are public, they will show some of those concepts in that design.
Can you give us an idea of the scale of the habitats that you're designing? Like how many people would be able to live in a building? Are these like condo, like?
The first phase is not very large. It's, I might miss this, so I'm doing this by memory, but I think it's 500 square feet is kind of the notional target that NASA has in mind. We could probably follow up if we really need to get detailed, but it's not very large for this phase because NASA's looking at some of their early missions. Certainly, I think as time progresses and we get into true long-term civilization and living right on the planet, not just visiting for extended period of time, but actually living on these planetary surfaces, these structures are going to continue to grow in size. And there'll be different structures, right? It won't be just habitats or places to live for periods of time, but there'll be needing to be more communal structures where people are getting together because there's so many. They'll have other structures with other purposes other than just habitation.
So
How are we going to compare the materials we have here on Earth versus the materials we may or may not have on Mars? Because I know there's going to be some stuff that's going to be really hard to bring from Earth to Mars, or maybe the soil may be inconsistent, may have different impurities in it. So have we gone that far?
So that's why the rules are kind of focused on rewarding more heavily a material that's based on basalt, for example, because basalt is readily available on the moon or on Mars. In this phase of it, of the technology development, they're just using basalt. The specifics of basalt on the moon or Mars and some of the other materials that might be in that and how it will affect the performance of this material, the structures of that, I don't think is what's being looked at yet, that level of detail.
One of the main challenges for people to habitate in outer space is radiation. I know that a lot of the tests have to do with being able to make it airtight and holding so much weight. Was there any consideration as to the materials that you're using or the design needs to be able to absorb radiation or shield the inhabitants from radiation?
So I don't think there's anything specific in the rules relative to looking at radiation. But in general, there is a focus on what is the structural performance level of the material. And in this design, I think we'll probably see some of them look at a design that allows them to, one example would be to actually excavate and then place additional regolith or the soil on top of the structure to increase that thickness, which will provide more shielding for radiation. So we'll see if we get some of those kinds of thought processes in the submission.
So even though you said you weren't heavily involved in phase one, with the majority of the submissions, were there any common shortcomings or things that were just overlooked by a lot of the submissions? Like, were there things that a lot of teams were just missing?
In phase one?
Yes, or in phase two. I know you said you weren't that heavily involved in phase one, but...
So in phase one, I'm not really sure because, I wasn't heavily involved. In phase two, though, there was a reduction in the number of teams that were able to compete as we progressed forward in those different levels. So printing a cone and printing a beam were one thing. We were able to have more teams. By the time we got down to head-to-head and actually printing that dome, which may seem relatively simple, but it is a fairly complex structure to do in this kind of manner because it's heavily overhang. So for the Penn State, when using a cementitious-based material, they had to have this inflatable type of structure that they could automatically collapse at the end. Actually, though, the branch technology approach, because of that polymer, so it was a certain percentage of ground, again, plastic bottles, and finally ground basalt. Their technique was to extrude that material out and heat it as they extruded it, which melted the plastic component. But then that plastic component will go and solidify again very quickly. That allows them to do more free-form printing. So they didn't have to have a form or a structure or anything else to provide support while they printed that dome shape, which was fairly advantageous for them.
Fascinating presentation. Really enjoying this. Curious in terms of how much the challenge considers the full life cycle of these presumed habitats. For example, if they need to be modified or extended in the future or torn down, right? In terms of the, like for example, if a structure is built with the polymer embedding, how is that recovered? Or is it recovered, or does it just become landfill? Has the sort of the full life cycle been considered at all?
Yeah, that's not really been a focus of it. But I do think that the material, this polymer mixed with basalt rock, if you will, type of material would have the ability to be recycled. I think you could take it down, break it back up into small pieces, and then repush it through, extrude it, heat it. I think it has the ability to do that.
So in the phase 3 right now, how many teams are competing right now? And what are the character of the organization that they're coming from?
So the teams are pretty widespread. University teams, small startups. I haven't checked recently. There might be a few that are more even single individual in a garage kind of setups. I'm not sure the latest count of where we're at with submissions in this last round. I think we are getting more though than we did previously. And
Dozen, 2 dozen?
probably between 10 and 20. So, and we'll see if we continue to get more as these teams are engaging. We continue to do events like this to get the word out. The rules are structured that people can still kind of get an on-ramp into the competition if they have a desire to do that, even though it's already started.
So I'm curious, how does Caterpillar view for its participation in what sort of yielding its investment on this? You know, how does this factor into your future product visioning and potential go-to-market and things like that? That's inherently part of the interest of this group as well in terms of connecting the dots on the other side.
So it's difficult for me to get and talk about details about what we might or might not do commercially in this. But I can tell you that this approach to looking at things is a little bit different. In that it's more of a process of incentivizing a large group of people to explore the problem, right? Versus a small group of people, focused funding, like Caterpillar and Caterpillar partnering with NASA and so on, but to cast a much broader net in terms of innovation and so on. Then on the backside is how do you take advantage of that commercially? And so there's different ways of doing that through licensing and other kinds of terms.
Let me elaborate on that question slightly. You touched on terrestrial applications of this technology. Do you see Caterpillar moving into space applications of this technology? In other words, are we likely to see Caterpillar bulldozers on the moon habitat?
I get that question a lot. So our focus of interacting with NASA and the aerospace community has really been, first priority is on what we call multiple use technologies. So technologies that NASA or the aerospace community can use and need to fulfill like NASA's missions, but that we can see value in meeting the needs of our customers and the industry bases, construction, resource industries, energy and transportation that we serve here terrestrially. It's very difficult to predict the crystal ball relative to off-world true commercial activities because there's so much variability in that, the timing of that, etc. But what I can say, I guess, would be that as humanity expands out into the solar system, are doing tasks like infrastructure, resource access, like we do, or Caterpillar helps to make possible here on Earth, that you can see by our engagement with NASA already, we will have had a role in doing that. Whether that role is what we're doing now to help bootstrap, move the technology forward, and others are using it to do that, or we are specifically engaged in that, I think that's yet to be seen.
When the technology for the basalt polymer mix won, how were they able to test or simulate the weather conditions like that would be on Mars, to test that it would be able to withstand the weather and the dust devils and stuff like that on Mars?
Yeah, so we're not really testing the environmental conditions of Mars. So, we're not testing at the temperature extremes of Mars or at the atmospheric condition of Mars. Certainly not the moon, although this technology could be applicable to the moon as well, because the moon is basically a hard vacuum. So we're not able to create those conditions at Caterpillar. That's not something that's part of our normal validation processes because our equipment's used here on Earth. But I would view this as the first steps of the technology development, the early phases, right? So as this continues to move forward, especially from a NASA focus on those planetary surfaces, I think they will get into understanding more details about what that means in terms of those environmental conditions.
Is that likely to show up in a phase 4?
I don't know. We'll have to see what NASA has in mind.
With the basal polymer construction, was there any sort of concern about leaching or any sort of environmental damage, like risks to people in a habitat that would be made with these type of plastics having been transformed or gone through some sort of transformation? Was that looked into at all, or?
It's not a requirement of the competitions.
Yeah.
I think it will be things that, NASA, for instance, will explore in more detail as the technology moves forward.
Other questions?
Is there a particular reason why did you get involved with the 3D printed challenge? Is it because of the money, because it's the most amount awarded to this project?
So,
Out of all 5, this has the most allocated grants.
Caterpillar has no involvement in the, so we're not providing the prize money, nor are we receiving any prize money. Our role is helping to support Bradley in the execution, providing them the facility for the competition, etc. And so our engagement in this is a competition that's very much focused in the key industry we serve, which is the construction industry. You can also see by some of the other sponsors that are involved in here, we have even some of our key customers, like Beckler Corporation as an example, we're also engaged in it as well.
Okay, so are you looking to get involved into the robotics challenge as well?
We're not involved in the robotics challenge. It's really focused on humanoid robotics. So NASA's, I'm missing the name, but at Johnson Space Center, the Valkyrie platform out of Johnson Space Center in humanoid robotics. So our focus of robotics at Caterpillar is really on field robotics, which is essentially taking our equipment and making them robots that operate in an off-road, outside environment.
With the whole open innovation concept that normally they set a challenge, not similar to how NASA is doing, but then they actually use that technology to implement into their industry. Is CAT planning on getting into some sort of 3D printing? You mentioned you could use this technology in a house. Is CAT now going to build a skid steer that can start molding houses or printing houses? Is that in the future of Caterpillar?
Well, like I said, I can't comment really on any details of what we might or might not do commercially, but this is a technology area that does hold promise for some of the industries that we serve. And so we'll see, we'll learn a lot from this activity relative to this technology.
Just last one, in terms of how much visibility does this CAT's involvement with this have within the broader Caterpillar employee population? How do folks, was there a group down in the cafeteria watching the live stream? Kind of how is this all sort of engaged with in terms of the employees and stuff?
So for the local Peoria community, many of those residents of the Peoria area that were coming in to view it were Caterpillar employees. And the students, of course, were coming in from the local schools, so many of them were the children of Caterpillar employees as well. So there was a fair amount of engagement. All right, thank you. I understand that you do have some more social time.
Yeah.
So I do have an actual physical sample of what this material looks like, this basalt polymer material looks like. So if people have some interest afterwards, you can come up and take a look at that.
Let's have another hand. Thank you very much. Very fascinating presentation. So thank you all for coming out this evening. You're welcome to stay and continue the conversation with Eric or with your person sitting next to you. I would also like to mention that New Space Chicago does run on your donations, so there's a box in the back. If you would be so inclined, we would appreciate it very much. We are taking a break over the summer. Our next event will be in September, so we look forward to seeing you all then. Thank you very much.